Okay, we're going to go ahead and do chapter 3.4, proof with perpendicular lines. You're not necessarily writing proofs. There are some questions in your homework where you have to write them, but we're kind of going over some more theorems that you have to know. So first thing, we covered distance formula in chapter 1. Yes, you will still need the distance formula, so please make sure you are practicing the distance formula. It says distance from a point to a line. So we've done distance. So here is my line. Here is my point. Most important thing is distance from a point to a line is the length of the perpendicular segment. So you have to understand that making sure whenever you are finding the distance from a point to a line, you have to take the perpendicular, you have to use the perpendicular line. Meaning it has to give you this little box right here. If the box is not given, we don't know it's perpendicular. So this is what you have to do to find it. You have to use the information that we know. Same thing with our previous test and quiz. You could look back on the assessment. You guys have to take the perpendicular line when finding the distance. Okay, you have to find the perpendicular line, which is the shortest distance from the point to the line. So make sure when you're doing that, you are able to identify the 90-degree angle. All right, looking at this example, again, we have dealt with this. You have to know the distance formula. The question says, find the distance from point A to line BD. Here is line BD. Again, you are taking the shortest distance. So you're going to take point AC. You're going to take segment AC. I'm going to go ahead and write the distance formula for you. For those of you who may have forgotten, you are going to have to memorize this for your upcoming test. So distance, formula is what we're using. The formula is, depending on how you remember it, I'm going to do x1 minus x2 squared plus y1 minus y2 squared. Yes, the formula we learned was x2 minus x1, but remember I showed you guys when you are squaring it, your answer is going to be the same. So this is the distance formula. This is what you're using when you're finding the distance from a point to a line. So this should all be more review for you. This should not be anything new because, again, we covered this in chapter 1. So when I am finding the distance, I have to, again, take the distance from the perpendicular line. So I am using AC. I'm using line AC for my distance. So I'm going to take A, which is -3, 3, and C, which is 1, -1. So now I'm going to go ahead and plug it into my formula, and then I'm going to solve. So, oh, I forgot to square root my whole formula. Oh my goodness. You're going to make sure you square root everything, because remember, we will have to simplify your radical. So again, please make sure you have the approved calculator for class. So again, if anything, I do have extra calculators for you. So how I'm writing it is I'm going to do x1, which is -3, minus 1 squared plus y1, which is 3, minus -1 squared. So changing what I can change, I can go ahead and make this a plus symbol. And I'm going to add. So right now I'm going to have -4 squared plus 4 squared. Keep in mind it's still square rooted. Let me use a little bit of a darker color. Next I'm going to have -4 squared is 16. 16 plus 16. Again, keep it in the square root. Then I'm going to get 32, not 36. The square root of 36. However, again, you're going to have to simplify your radicals. So, simplifying this, you can use the factor tree method. I have 16 and 2. Please do not forget, I did not pull out a perfect root yet. So, it's going to stay in the radical. I know 4 times 4 is 16. So the square root of 16 is 4. I cannot do anything to my 2, so simplified, my answer would be 4 times the square root of 2. That would be my answer. On big ideas, you have to change it to a decimal. So you can plug it into a calculator, the square root of 32, and you will get a decimal. That would be your answer for big ideas only. Again, big ideas is asking for the decimal, which if you plugged it into a calculator, I believe it would be 5.65, but rounded to the nearest tenth, 5.7. Please don't forget to round if it asks you to round to the 10th. But on the test, answer that will be acceptable would be this one right here. You have to make sure you're simplifying it to the simplest radical, and again, you will be given a calculator if you don't already have one, and it has to be the correct approved calculator for class. All right, perpendicular bisector. Using context clues, we should know what this means. Perpendicular, we again should know this word. It means it's a 90-degree angle. There's my perpendicular symbol. It's that upside down T. And then bisector means cut in half, okay? Bisector, okay, cutting in half. So the perpendicular bisector of line segment PQ is the line N with the following two properties. So line N is perpendicular to PQ. Keep in mind, the only thing you can bisect is a segment. You cannot bisect a ray. You cannot bisect a line. You can bisect a segment because, again, rays continue in one direction forever. They never end, so you will never be able to find the middle. Lines continue on both directions. Again, you cannot find the middle of a line. But segments have two endpoints. So where are my endpoints looking at segment PQ? Right here. That means I can cut it in half. N passes through the midpoint, which is M of PQ. So, perpendicular bisector, what do you have to look out for? Looking at my diagram, I have to find that 90-degree angle, and I have to have these two congruent marks shown in my image. So again, I will go ahead and write it down. You are looking for your right angle and your congruent marks. Okay, those little tick marks right here that are showing you that your lines are congruent. However, what cannot be a perpendicular bisector? If I were to draw something that looks similar, however, here is my line, or you know what, not a line, here's my segment. Let's say I'm using the same thing, P, Q, N. Yes, if it has my segment marks, okay, check, it has my segment marks, but it does not have my right angle, okay? This is just a bisector. It's not a perpendicular bisector because remember, perpendicular means right angle. This is just a normal bisector. Your segment is just being bisected, and the line is not perpendicular. So just keep that in mind. Perpendicular bisector, you have to have your right angle showing you that it's a 90-degree angle, and you have to have your two congruency marks. Linear pair perpendicular theorem. So, again, using context clues, linear pair, we should know what this word means. If you already forgot, I'll go ahead and write it on here. Oops. Linear pair. Two things a linear pair has to be. One, adjacent. If you forgot what adjacent means, it means next to. Okay, keep in mind adjacent, you are sharing a side. And it has to be supplementary, meaning you add two angles. Angle plus angle equals 180. So you have to make sure you are adding two angles. And then perpendicular, like I said in the previous slide, that just means 90 degrees. So we have linear pair perpendicular theorem. It says if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. Keep in mind, this does not have to show you a right angle. Because they're showing you those congruency marks, if this is a straight line and you're splitting your supplementary line in half, it has to be 90 and 90. So you should already have an idea that these angles are 90 degrees. Okay, again, linear pair, they share a side. So here is my side that they share. And they are supplementary, so this angle is going to be congruent to this angle because of my congruency marks. And again, if they are congruent, then that means they're both 90 degrees. So, looking at this one, giving you an example. Yes, I can have a linear pair. Let me show you an example of just one pair, just one linear pair. Oops. A little straighter. Okay, here is a linear pair. This is my supplementary line right here. Okay, they are both sharing this line. However, they are not perpendicular. So if I had 70 degrees, 110, it may look like it's a linear pair perpendicular, meaning I can use that. However, this is not congruent. My angles are not congruent. Line N, let's just name this line N, is not perpendicular. Okay? They are not congruent. And this is not perpendicular. It cannot be perpendicular because I have 70 and 110. So just be aware of that. Yes, you may see things that are not perpendicular, and then if not, or not a linear pair, just be aware of the theorem because you will get tested on proofs for this chapter. All right, perpendicular transversal theorem, again, context clues. Perpendicular means it's a right angle. Transversal, we have dealt with transversals. We just had a quiz on transversals. This is my transversal right here. J is my transversal because it's being cut by two lines in two different points. So here is my transversal. In a plane, if a transversal is perpendicular to one of the two parallel lines, again, how do I know that these lines are parallel? If you're looking at them, I know they're parallel if they have these arrows. So please understand they are parallel if the arrows are showing. So again, if a transversal is perpendicular to one of the two lines, then it is perpendicular to the other. Then I know it is perpendicular here as well. Again, if it's perpendicular on one of the parallel lines, then the second line must also be perpendicular. So some of you may have noticed this in class. Okay, if this is 90 degrees, won't all the other angles be 90 degrees if they're parallel? Yes, that is true. That is perpendicular transversal theorem. So look how it's written. If H is parallel to K and J is perpendicular to H, then J is perpendicular to K. So please be aware of that. This is perpendicular transversal theorem. This one's the opposite of the previous one of perpendicular transversal theorem. This one is lines perpendicular to a transversal theorem. So if you're looking at this, notice how there are no arrows on my lines. So we cannot assume that they are parallel. However, if my two lines, oops, let me grab my highlighter. If my two lines are perpendicular, so 1, 2, to the same line, meaning my transversal, then they are parallel to each other. Then I know that they are going to be parallel. So again, I'll repeat it. If two lines are perpendicular to the same line, then they are parallel to each other. Then I can say they're parallel. Again, the last one stated, if a transversal is perpendicular to one of the two parallel lines, then it is perpendicular to the other line, stating they're perpendicular. But lines perpendicular is stating if my lines are perpendicular to the same line or to the transversal, then they are parallel to each other. So I'm showing you that they're parallel. This is a theorem I'm using if I have to determine that my lines are parallel. So reading this, if M is perpendicular to P and N is perpendicular to P, they're both perpendicular, then these lines are parallel. Okay, this example says the photo shows the layout of a neighborhood. Determine which lines, if any, must be parallel in the diagram. Explain your reasoning. So looking at my diagram, let me zoom into the diagram so we could see it. So looking at it, I have S, T, U, P, and Q. Let me write it on the outside so we can see a little better. Here is line S, here is line T, U, P, and Q. Oh, the Q looks a little weird. Okay, they want me to determine which lines are parallel. Again, keep in mind, let me see what my parallel lines are. I have one here, I have one here, and I have one here. So going back, lines perpendicular to a transversal. Remember, they are giving me two lines that are perpendicular. I am then stating if the two lines are perpendicular, then those two lines will be parallel. So we have to go ahead and look what's perpendicular. So looking at what's perpendicular, what do I have that's perpendicular? I have lines P and Q. Let me use a lowercase q. Are perpendicular to what line? So here is P. I will highlight it or circle it so we can see it. Okay, here's P. Here's Q. Again, they're on two separate lines. What is my transversal? My transversal is going to be S for this one. So lines P and Q are perpendicular to S. Okay, meaning to line S. If you want to put the word line, that works. They again want me to explain my reasoning by what? If they're perpendicular to lines, it is by lines perpendicular to a transversal. Again, we are still working with transversals. What else is parallel? Okay, so I got PQ, and now I see another one. Let me circle it. I have S and T. Why am I saying S and T? Because I cannot say Q and Q. Okay, I cannot say Q and Q. Yes, it's on line Q, but I can't state it's line Q and Q. So I am now going to say lines S and T are perpendicular to what line? Again, looking at my diagram, I have two lines. Let me use a different I have 2 lines here. Here's 1. Here's 2. I have 2 lines cut by, they cut a transversal. So this is my transversal. That is Q. So I'm going to go ahead and write it in. Lines S and T are perpendicular to Q. And again, we did S and T. By what theorem? Same theorem as before. If I have 2 lines that are perpendicular, they are cutting my transversal, so I have lines making them parallel, perpendicular to a transversal theorem. Okay, so S and T are parallel. If you're wondering how to write them, P is parallel to Q, and we know S is parallel to T. So that's what you should be stating for example 2. Again, determine which lines, if any, must be parallel in the diagram, and we found that using the lines perpendicular to a transversal theorem. Alright, you guys have 3.4 homework. Please check the description on which questions to show work for. Please again turn in your notes at the end of class, and you can go ahead and get started on your homework.